of silver lining that you want to share?
Isn't it like in every bad thing, there's always some sort of good thing, like the silver lining to a dark cloud?
Yeah, it's interesting that you say it that way. Do you guys believe that that's true? Do you believe that there is always a silver lining in everything that's bad? How about you, Ben L? And what about you, Hannah?
I don't think, I think there are some things that don't really have it.
You think that there are some bad things that where there really is no silver lining?
Yeah,
Yeah, there might be. Like for instance,
poverty, homelessness, stuff like that.
homelessness. But when people deal with homelessness, sometimes they get help that they never otherwise would have had. Okay. And maybe that's the beginning of their life turning around. And so that could be a silver lining. Now, can you imagine that there is an amazing silver lining? So again, my definition is the same as yours. A silver lining is when something great comes out of something bad. And can you tell me, other than what you saw on the PDF that you printed out, what are some of the silver linings, the other silver linings about this COVID process? Angeliki?
Well, it was on the news, and in I think it was in France. There was less noise pollution.
Less noise pollution.
Yeah.
Wow. I did not think about noise pollution at all, Angeliki. Very cool. Anybody else want to share? Go ahead, Bridget.
Uh, my parents think this is a silver lining because we're not eating out as much and we're making a lot more meals at our house.
And why is that a good thing?
Like
Explain.
we're eating healthier almost. So
You're eating
we'll
healthier.
probably continue it.
That's right. That's right. And what do you think, Cedric? What do you think the silver lining is with this COVID situation?
Uh, Maybe like people have more opportunities to like do stuff that like don't get to do normally.
Yeah, like what would that, can you give me an example?
Maybe like learning a new language.
Ooh, it's really interesting you say that. I would have loved to have learned, I'm still working on English, so I never learned another language. Maybe that's what I should do now. Hannah, what about you? I want to hear from you. What do you think is a silver lining that's come out of COVID?
Well, the population is kind of, it's not rising as much.
Ooh,
So
interesting.
it's not.
Kitty.
That's actually fascinating. I would be interested to know if the population is really being affected and how that works. And David, I want to hear from you as well, and then Francesca, and then Olivia, I'm going to be asking for you to share. Go for it.
The silver lining, I think, is that we learn how to recover from this. Like before, the reason this was so bad was because we didn't know how to react to this. So this is better for us because now we know if this comes up again, how to react and what to do and what not to do.
I think that is one of the great silver linings of this, David, that we are learning so much about what to do and also what not to do. Fantastic. How about you, Francesca?
So I'm kind of adding on to what someone said earlier. We can also spend more time outside, or at least that's what it's in case for like me and my family, because we have a lot of things that we do when it's not like this, and now we're having a lot more time that we can be outside.
Wow. I think that is one of the great silver linings. I really love it. And just Ellie and Ben, change your name there. please. And Michael, do you want to share?
I don't really have anything.
Okay. And Olivia, can you share?
Well, it's just really nice staying home.
Yeah, I mean, and it is. And Ellie and Ben, we were talking about the silver lining that comes out of a bad thing. And COVID certainly has a lot of silver linings. One of the things that my younger students, my first graders, they all were so excited about spending more time with their mom and dad, because a lot of the moms and dads work, right? And actually, Bridget, can you not do that? It's a little distracting for me. And so I think it's important to know that there's always going to be a silver lining. But the biggest one, guys, the biggest home run, in fact, it's a grand slam home run, guys, is the reduction of pollution. And I want to talk to you about the science going on here. It's really quite extraordinary. So since COVID-19 and they essentially closed down so much industry, scientists are calling it, oh, hi, Walker. We're talking about the pandemic and the silver lining that's come out of the pandemic. So let me just sort of explain what scientists are saying. They're saying that it's the largest scale experiment ever into global air quality. Now, the way they measure global air quality is by doing something called, they're testing for nitrogen dioxide, which is 1 atom of nitrogen, 2 atoms of oxygen. Together they make a molecule called nitrogen dioxide. This is the most toxic gas produced from cars and factories and things like that. And they create an amazing amount of problems for people with asthma. They also reduce our immunities by creating more inflammation, which makes us more susceptible to bacteria and viruses and microorganisms, which of course cause disease. The other thing is, guys, can you imagine what's happening in the farming industry? Farming industry, the things are growing way more healthy than they ever have. It's quite amazing. Michael, do you have something to add? Michael, you raised your hand?
It was an accident.
Oh, okay, no problem. So in the farming industry, vegetables and fruits and wheat and everything that they're growing is growing at a much healthier rate. It also has it's also saving on waste that goes into our landfills. Now, let me give you the litmus test. Scientists basically look at 1 cubic meter of air. Now, can you guys just hold your arms about 1 meter apart? And 1 meter, guys, is about 39 and a quarter inches. And if you do 1 meter length, 1 meter width, and 1 meter height, and you fill up all that space, that's called 1 cubic meter. Do it again. Cube, cube, cube. Just for fun, mathematicians, don't answer it out loud. Think about it. How many cubic centimeters is a cubic meter? Remember, centa is 100. So that's all I'm going to give you. And if you can send me a chat with your potential answer, I'd appreciate it. I'm looking for the number of cubic centimeters. Cedric, give it another shot. Yeah, Ben, I don't agree. Ellie, you're close. Ben may have had it. Ben, I don't think you're there. David is there. Ben L is there. Bridget is close. And 100 cubic centimeters, no. Okay, really cool. So let's just talk about this for a second. So I'm going to throw some numbers
Times 100.
up on the screen here. So 1 meter, guys, is 100 centimeters. And therefore, if you take 100 times 100
Times 100.
times 100, it's a 1 with how many zeros after it?
6.
And guys, there are literally 1 million cubic centimeters in a cubic meter. Now, you see these little yellow dots? I didn't do the math very well, but if there are over 200 micrograms of NO2, of nitrogen dioxide, in a space of 1 million cubic centimeters, it is unhealthy for humans. Now, that's what the World Health Organization, otherwise known as WHO, WHO, is the World Health Organization. Now, I want to show you something kind of fun. We're going to talk about converting micrograms to meters. So in every little cubic centimeter, there are 1,000 micrograms.
Whoa.
Okay, there are 1,000 micrograms in 1 little cubic centimeter. Now, 1 cubic meter, as we know, is 1 million cubic centimeters. And therefore, 1 cubic meter is going to be how many
1
micrograms?
1 billion.
And the answer is 1 billion. So if you take the ratio that the WHO gives us, they're telling us, and don't say it out loud, but 200 micrograms of 1 billion is considered the level where it is unsafe. So what is the fraction of our air that must be nitrogen dioxide for us to have unhealthy air? Can you guys please simplify that fraction for me and send me a quick chat? By the way, I am not writing down the answer. This is not the answer. It's going to help me get there. Oh, nice. Nice, nice, nice. So do you guys see what I did, that I divided top and bottom by 100 first? And then I divided top and bottom by what? Come on, say it. You guys can say it.
No.
Then I divided top and bottom by 2, getting 1 part per 5 million. Now, this is really important mathematics. Olivia, I can't see you. I don't know what's going on. Okay, great, much better. So 1 part per 5 million of a cubic meter has to be of nitrogen dioxide. Now, here's what's going on right now worldwide. In January 20th, 2020, this is about 4 months ago, if you look at the NO2 density chart, anything greater than 200, this is where 200 is right here, guys. Do you see it? Anything greater than 200 is considered unhealthy. So all this area around China, this is where Beijing is, right about here. This is Wuhan. It is all unbelievably unsafe. Now, 1 month later, 3 months ago, look at China now. Isn't that amazing? And that's not even today. This is now 2 months ago. Can you imagine how clean it is today? Now, my father used to live in South Korea, and South Korea was never that polluted back when he lived there about 60 years ago. Now, in the last 2 to 3 decades, South Korea has become unbelievably populated, but also very unhealthy for pollution. They have reduced their NO2 levels by 54%. China, overall, 25%. Now, why do you suppose that Italy, up in northern Italy, has all of this horrible air? What is up above it right over here? Can you raise your hand electronically to tell me what is north of northern Italy that would somehow create pollution in northern Italy? Any ideas? What could be like a wall that would prevent a southerly wind from dissipating the pollution?
The Andes.
Say again?
The Andes.
Oh, very close. Now, the Andes is a mountain range in South America, but it does start with an A. It's called
Alps.
Alps. So the Alps mountain range acts as a wall, and all the pollution comes up against it, and it can't go anywhere. But guys, 1 year later, look at northern Italy now. It's unbelievable. Now, I have to show you this. This is Wuhan, China, which is where the pandemic began. One of the dirtiest places on earth from a pollution standpoint. February, about 14 months ago, the levels of NO2 were unbelievably high. Guys, look at it today. Isn't that clear? I mean, I almost want to go to Wuhan because otherwise I would never, ever have thought about going there. Now, the reason I taught this lesson this week, my son sent me an article that blew me away, and I want to show you it right now. He said that there were people that lived next to one of the tallest mountain ranges in the world. In northern India, people live, and Olivia, if you could put the cat down, that'd be great, because then I think it'll be a little bit less distracting. Thank you, honey, I appreciate it. So this mountain range, can anybody tell me what mountain range is north of northern India? Anybody want to share? Who can think of the mountain range? You know, the Andes is in South America, the Alps is in Europe. What's the big one in Asia?
Mount Everest.
Oh, yes. Mount Everest is actually about a few hundred miles east of here. It's called the Himalayas, and I don't know how to spell it, but maybe I can find the spelling here. The Himalayas, there it is. So the Himalaya mountains, okay, have not been seen by millions and millions of people for the last 30 years. The mountain range has been behind a wall of pollution. Now, this is what blew me away. The education level in India is so low in northern India that people didn't even know the geography of where they lived. They didn't even know that they lived near the tallest mountain range in the world. Now, this is what it looks like, guys, in Delhi. Delhi, India, which is one of the worst smogs in the entire world. This is what it looked like normally. So this was essentially 1 year ago. This is 2019, and this is 2020.
Whoa.
This is what it looks like now. You can actually see the sky, and I almost get teary just thinking about how these people live and how they're living now. Now, I want you guys to think about a few other places. In France, this is Paris a year ago. This is Paris today. Now, in Spain, Madrid, and then Madrid today. Even Barcelona was very polluted, and then today it is not. Now, what do you guys think is happening in the United States right now? Do you think that we have had an equal reduction, or do you think that not much of a change? I want to hear what your thoughts are. Angeliki, I can't see you. I can only see the top of your head. Who wants to share about what's going on in the United States right now? Anybody want to share? Come on, guys. You can do that.
It might be the same.
I think it's going to be a small reduction
A small reduction. Why do you think that, Ben?
because even though like there's been a global like lockdowns, there like people have still been going outside and in their cars, and
You know,
I think
it's interesting. In India, they actually instituted something called a curfew. Now, a curfew means that you're not allowed to drive at all. You literally have to stay at home. Whereas in the United States, some states said, we'll do this. Some states said, we'll do this. Today, guys, Cambridge and Somerville, Massachusetts, those are two cities in Massachusetts, said that you have to wear masks. But Boston, it's recommended, not required. So I think that you're right, and it's very interesting, but I want to show you, guys, this is the Northeast. Now, do you notice all these states? What state is right over here, guys?
Maryland,
Good, good. What state is right over here?
Pennsylvania,
What state?
New York,
What state?
Vermont,
Good. What state?
New Hampshire,
What state?
Maine,
And what state?
Massachusetts,
And what state?
Connecticut,
Connecticut,
Now, look at this guy.
New Jersey.
New Jersey.
Oh my God. Can you guys look at New Jersey, New York City, Long Island, all the way out, all the way out.
terrible.
This is one of the worst levels of NO2 particles. Now, I want to talk a little bit about this scale. This was taken by a United States satellite called Aura. And it's launched by NASA. They use something called ozone monitoring instruments. And they use a scale that is parts times 10 to the 15th power. Who can tell me what is the number of 10 to the 15th power? Please send it to my chat. I'm looking for 10 to the 15th power. And I'm wondering what that number is. If you could send it to me by chat. Oh, that's nice, Ben. And can you, oh gosh, Ben B asked, should we inject Clorox? Ben B, the answer is no. We should not inject Clorox. It can be, it's toxic and can be deadly. But I'm not a doctor, okay, or a scientist. So I would say ask your parents, your physicians, but do not listen to the person who is telling you to inject Clorox.
I think people died from doing it.
Yeah, it's
Not
I mean, I'm not going to say the word insane because that is emotional, okay? I'm going to say find out, do the research, do the diligence. But Ben, you ask a good question. Now, nobody named the number. Everybody told me that it was a 1 with 15 zeros behind it, who can tell me what the name of that number is? Anybody on 3? 1, 2, 3, go.
Quadrillion.
1 trillion.
It is 1 quadrillion. It's 1 quadrillion. Now, in New York, you know that there are levels of between 8 and greater than 10 quadrillion parts of molecules of nitrogen dioxide in every cubic centimeter.
Oh,
Pretty nasty. Now, even Boston is a little suspect. But guess what, guys? We have had a reduction of 30% nitrogen dioxide levels in all of our major cities, Washington, D.C., New York City, Philadelphia, Boston. Now, even New York City still looks bad, but I want you to look at it, guys. The area is so much smaller. So I'm going to show you both pictures at the same time. You guys see that?
it's a lot better.
It's a lot better. Now, I want to ask you guys, what's going to happen when the pandemic is over? Do you think our pollution levels are going to go right back to where they were?
Yeah.
I mean, it might go up a little bit, but people might learn from this, like, oh, actually, it's a lot healthier to not do this. So maybe we'll change a few things.
I think
Yeah.
it's going to be right back up.
Go ahead. Go ahead. Go ahead. Who was speaking? Go ahead. Francesca?
I think that like it's still gonna go back up, but I don't think it's gonna be as bad because like some people might notice and they might be like, oh, and also like that it got like that polluted because it had probably been like that for a long time. So I think it would take even a long time for it to kind of get back to that polluted. So I think people might notice before it gets that polluted because it's gonna be like.
Yeah, guys, I think it's the greatest experiment in human history. I really do. Angeliki, what do you think?
I think it's gonna kind of slowly transition back in because, like, now what we've been through today, people are gonna want to like let it clear out and then start transitioning back into their normal lives. And yeah.
Right. I really hope, guys, I only pray because they say that 7 million people a year die worldwide because of pollution. Okay. And 7 million people, guys, is a little less than 1% of the population of the world. So it's a big number. One out of, let's call it 1 out of 150 people, right? Or maybe 1 out of 100. That's a huge number. And so I'm willing to make sacrifices. The question is, can I find a solar powered boat? Okay. So for instance, that's one of the things that I'm actually looking for is, does it exist? Is it something that's feasible? Bridget?
No, I don't think many people are educated on it. So I think it's just gonna go right back up.
Mm-hmm.
Oh, wow. So guess what, guys? You, in a way, now that you are educated in this, I think you have a moral obligation to talk to your friends, even share this PDF, okay, and take them through this. I mean, look, this is one of my favorite things to do. Look at this particular map, and this is on your page 6. If you look at Rome, Rome is the only major city that has an increase of 30% in pollution, in nitrogen dioxide. Does anybody have any theories behind why every other major city has reduced significantly? I mean, look at Delhi, 60% reduction. Francesca, what do you think?
Well, this isn't exactly a reason, but sort of is. Like, if the weather is different in different places, will that like impact?
Cedric, is that you, buddy? Okay, I hear a ringing noise on someone's computer. Francesca, I'm sorry. Go ahead, sweetheart.
If the weather is like different, like will that change anything?
Yes. So the weather, when it rains, it's actually good for pollution. It actually helps dissipate the micrograms of nitrogen dioxide. So weather has a big impact, Francesca. You asked a great question. Does anybody have any theories about Rome? Because I have a theory. I don't know if it's correct, but I wanted to hear what you guys had to say about Rome. David, go for it.
Maybe it's all the people traveling there and all the like planes and buses that fly in.
Yeah, but they really, Italy has pretty much been shut down since March. And so, David, you're right. That would be a great reason. Angeliki, what do you think?
Maybe all the doctors like trying to get to the hospital because there's a lot of people that are sick.
Wow. Angeliki, I have to tell you, that is a really logical answer. Ellie, what do you think?
It might actually be because people are trying to get out of Rome
Ooh.
because it has a lot of like coronavirus, and they might be trying to go somewhere else.
Yeah, you know, it's very interesting, guys. This is the theory that I have. Do you guys know what happens when it's very cold? What do you turn on in your house?
Wait, what?
When it's really cold, when the climate is cold outside, what do you do when you're inside the house?
Turn on your heater.
Turn on the fireplace?
And you turn, well, you know, most people now have electric or gas heaters. And the heaters have these engines, these little, they're really engines. And they make a fan turn and it creates heat to go throughout your house. Now, those are outside of your house. They're usually on your roof or outside. They give off a lot of nitrogen dioxide. And in Rome, this particular winter, it's been very, very cold. Also in Rome, people don't stay at home a lot. They're always out. They're always out moving around. Well, guess what? Bad combination. Very cold. Everybody's at home. They turn their heat on at the same time. And oh my God, the heat creates a lot of pollution. So that is my theory, but it doesn't explain how northern Italy has reduced so much, and it might be just simply the factories. But what I had the younger students do today is I had them shade in the percent reduction for Los Angeles, let's say, and they would shade in 31%. So go to page 6 in your packet right now. And I'm just gonna have you do a few of these. I want you to shade in, how about Seoul, Korea? And I also want you to tell me how much pollution is left as a percentage. So shade in the reduction on Seoul, Korea. And then tell me how much is left. And yes, these bars are separated into tenths. So who can tell me what is the amount of pollution that is now left after we reduce it by 54%? It's called the complement. What is the complement of a 54% reduction? On 3, say it. 1, 2, 3.
46%.
So 46% is pollution of the total that Seoul had in the past. Now I want to ask you, what are we going to do about Rome? How are we going to show a 30% increase? What do you think we ought to do? Anybody have any ideas?
You're gonna have to do it like backwards. You're gonna do it-
Backwards is fine. Somebody give me, Francesca, give me an idea.
You could just like make it longer, the like bar thing longer,
How
and
much longer?
by like 3 square things, and then you break them up into squares, and then you can like show how it's added on, or you could shade it like a different color or something for the part that was added on.
Yeah, and raise your hand if you can tell me what percentage, raise your hand if you could tell me what percentage of pollution is left in Rome from its 100%. On 3, 1, 2, 3, go.
130%.
And guys, guess what? Rome has now 130% of pollution that it had before. Not a very impressive thing. Don't go to Rome right now, please. Now, I want to talk about something a little more interesting. Last week, we talked about the circle graph, which is essentially our globe, latitude, longitude, correct? And how many degrees has the circle?
360.
Okay, if you break it up into 10 parts, each part is how many degrees? You can say it out loud.
36.
It's 36. So 360 divided by 10 is 36 degrees. Now, how do you think I did these tenths so accurately? And by the way, just so you know, I cheated.
Use the computer.
I did use the computer, but what did I have the computer do? Ellie?
Make like good circles.
Yeah, I had the computer make a circle, but how did I split it up into tenths so accurately? We're not very good in this country of doing things into tenths. That's more of a European thing because it's the metric system.
Did you do like
Hold on,
some
raise your hand electronically just so we do this in order. Francesca?
Like maybe this has like a tiny ruler, and you can use the tiny ruler to like measure stuff. I kind of wish it had a tiny ruler if it doesn't have a tiny ruler. So I suggest they add a tiny ruler.
You know what? They definitely do have a tiny ruler. David, what do you think?
maybe use like a different shape to set markers for the circle, and then you just use like,
Are you guys ready? What do you think I used?
Smart.
I used a regular what? Hexagon.
One, two,
Now guys,
three,
look
four,
at the
five,
tool.
six.
Can you guys see the tools that I just
12
pulled up?
Hexagon thing.
a shape thingy.
Yeah, so this tool allows you to have a 3-sided regular all the way up to a 16-sided regular polygon. And so what I did was I overlaid it on a circle, and then I literally just went from those points. And then because I wanted to show you a really cool circle, I then hid my shape. But trust me, it's hard to do. So I want everybody right now to go to page 8 in their packet. And the first thing I want to do, and by the way, in this country, we are really good at splitting circles into what?
Fourths?
Yep. And
Fourth.
and what?
Twelfths.
Eighths. And what?
16th.
And what?
20 seconds.
16ths, 30 seconds.
64th, 128th, 256.
Good. Now hold on a second. In the metric system, which is used almost everywhere else in the world, they are all about 5s and 10s. I can't believe that we don't use the metric system. If I started this country, it would have been metric all the way. Now watch my method. What I do is I want you to go to Sao Paulo, and I want you to draw a vertical line, a diameter, straight through the center, please, of this circle. And then mark the center, please. Cedric, you have that? Good? And I don't, and Cedric, you're muted, so I can't really, and Hannah, I can't see you either. There you are. Excellent. And okay, now, do you guys see the semicircle?
Yes.
Yes.
Okay. I want you to break up the semicircle into 4 equal parts. We're going to break the semicircle into 5 equal parts by giving us 4 equal points.
4 or 5?
Well, you split it up into 5 parts by creating 4 dots that are equidistant from your diameter. Let me know when you've got your 4 dots. Walker, are you there? You got it? Walker, do you have yours? Walker, I can't hear you. I think you're muted.
Yeah.
Yeah, you got yours. Okay, good. Now, take your pencil now and draw a straight line from each dot through the center all the way to the other side. And it's not going to be perfect. As we know, it's pretty easy to do with 8ths and 16ths, but you get pretty good at this.
Boom.
And also, Bridget, could you turn off your virtual background because I can't, you're like obscured through it. Can I see your circle tents, guys? Ooh, looks good. Looks good, everybody. Wow. Ben, how about you? Ben B?
I messed up.
Okay, do it again. That's why you've got so many choices there. Okay, now, I want you guys to watch this. We're gonna shade in 33%, so go ahead. Remember, each one is 10%. So you're gonna shade in 3 of them. And then how much of the 4th one?
3%.
Yep, about a third, which is actually 33% of the 3rd one. And then I want you to write the degree measurements, guys, inside each one. So this guy has a degree measurement of 36 degrees, 36 degrees, 36 degrees. Each 10% is 36 degrees. Now, what's the degree measurement in that little third of 10%?
12%, 12 degrees.
12 degrees.
12 degrees sounds pretty good to me. Now, why don't we now add 36, 36, 36. Don't call out the answer. 3 6s give us what, guys?
18.
And 18 and 2 is?
20.
And carry your 2, please. You're grouping, and you get what?
11.
Not quite.
Oh, 12, sorry. 12.
And therefore, the degree measurement of the pollution reduction in Sao Paulo is 120 degrees, which of course equals our 33%. Now, can I ask you a question? What happens if you were to multiply 120 by 3?
360.
360. So this is what I want you to do today. I want you to work on that, okay? And you guys can pick whichever one you want. And what I want you to do is I want you to do pretty good estimates and then add 36s. So a fun one might be Delhi, where you had 6 36s. Don't say it out loud, but it's actually a very special number. 36 times 6. Don't say it out loud, but it's a very, very special number. So get working, and please raise your hand electronically if you have any questions right now. And I'm really interested to see what you do with your estimates. So if you have any questions, it'll be a great exercise to go through thinking about them. Now, while you're doing this, I'm just going to give you a little thought that I had. The next time your parents say, let's go on vacation, I think it's a really good idea for you guys to check the NO2 levels of that city. What do you guys think?
Yeah.
Yeah.
Yeah. I mean, why not? I mean, it's your health, right? It doesn't mean you have to have asthma. I mean, it's just anyone can be more healthy. I'm going to work on Seoul right now. Makes me think of my dad. And so 54% reduction. Ben, which one are you working on there? Ben B.
The Madrid one.
Which one?
The Madrid one.
Oh, cool. 11, that's 11%. So how did you do on your estimate with that little 1% piece? What did you use as an estimate there?
I'm still working on it.
Okay. And 4%, so 4/10, 2/5 of. Does anybody have an algorithm for 36 times 5 that they can help me with? Don't give me the answer, but I want an algorithm. Who's got an algorithm for 36?
I do.
Who's I?
Ben,
Olivia. Oh, is it Olivia? Okay, Ben?
So divide the number by two. Divide the number you're dividing by 5 by 2.
You mean divide the number you're multiplying by 5
Yeah.
by 2?
Yeah,
So
divided by.
I'll do that. So 36 divided by 2. Ben?
Which is 18.
And then?
Then you just shift the place value to the right, which is just tack on a 0 for it.
So really what we're doing is we're multiplying that by what?
10.
By 10. So that's a great way to get 180. Okay, the way I do it, Ben, also, is, can you watch this, Ben? And everybody else should as well. I will first multiply 36 by 10, and then I'll divide by 2. So I'll go 3, what's half of 360? 180. But either way is really cool. And then 180 plus 14, I get 194 degrees, which I think is pretty close to the actual answer. Who's got some that they can share right now? What about you, Cedric? Do you want to share? Which one you're doing?
I just
Who can share? Somebody raised their hand, but I can't see it. Let's see. Who raised their hand? Maybe you can just speak out loud since I can't see it right now. Oh, by the way, there are 3 people that are muted, 4 people. Can anybody share one of them that you've done? Go ahead, Bridget.
I did Delhi and I got 216.
Oh, nice. Who can tell me why 216 is such a special number? Does anybody know why 216 is such a special number? Everybody focus now. Really important. 216, guys,
Cubed.
is 6 cubed. It is a cubic number. So 216 degrees is 6 cubed, and that is Delhi. How about Madrid? Ben B? What'd you get for that?
I think I got,
What did you add to 36, Ben? For that little 1%?
I added 3.6 and I got 39.6.
All right. I mean, I would have added 4 as an estimate, but you went for the actual answer, right? Because 3.6 is actually 10% of 36. So really, really nice, Ben. But I really want you guys to go for estimates on these because they're really fun to make. All right? They're really fun to make. Now, everybody take a break right now. Everybody take a break, and I want you to look at the answer key. So the answer key actually gives you actual. Now, Rome is kind of fun because I had to create three 10% to represent the 30% on the outside. But these numbers will give you the actual answers. And if any of your estimates are within 10 degrees, you're doing just great. Now, the last thing I want to focus on here is this. There's a scale called the Air Quality Index. And I gave you 102 different cities in India. They're a little bit hard to pronounce, but these cities are pretty amazing in the work they've done to reduce their NO2 level. So you can actually do the differences between these numbers. If the numbers go up versus if the numbers go down. This was in a 24-hour period after the curfew started. Remember, the curfew was called the Janta curfew. Why is the Janta curfew so famous? Can anybody tell me why it was so special? Ellie?
Was it the first curfew?
It actually was not the first, but that's a great guess. Why was it so amazing, Bridget? Go ahead.
Was the biggest curfew?
It was the biggest curfew the world has ever had. Does anybody know how many people live in India?
A lot.
Anybody know the number?
Like over a billion.
1.3 billion people were ordered overnight. In fact, I think it was on March 23rd, 2020 at 7 a.m. is a date that will live in infamy because I think it changed the world forever. I mean, can you imagine being so ignorant and not knowing that you live next to a mountain range? It should never happen. So I think that people are going to want to increase education now in India. I think they're going to want to reduce pollution. I don't think they're going to accept the old ways anymore. And I want you guys to help, okay? You are mathematicians. You are the smartest minds right now, and you could actually make a difference. There was that little girl, I forget her name. She's an advocate for reducing global warming, and she's from Sweden, I think, or somewhere in Scandinavia. She's like 13 or 14 years old. She's changing the world. Do I love her tactics? Actually, I do. She basically says to us adults, she goes, shame on you, okay? And I want you guys to think about ways that you could make a difference. It's amazing what can happen with beautiful minds like yourself. So I want you to work really hard towards it. I wanted to show you the last thing. This is in your packet. And what it is, it's showing a 13-day period in India, and it's showing all the different cities that are good, they have good air quality to very poor air quality. So the higher the AQI, the worse is the air quality, okay? So it's amazing, guys, but it's gone from March 16th, there were 50 cities with average air quality, around 12 cities with poor to severe. And then look at what happened as the days go on. And guess what happened on March 29th?
0.
0 cities with poor air quality. Now, guys, if that doesn't make you smile, I don't know what will. So I want you guys to get outside. I want you to breathe in the fresh air. Everybody breathe with me. Come on, breathe with me. Because the air is free of these micrograms of NO2. And that is a cause for celebration. All right, guys, let us count. Let us count from 1.3 billion, negative 1.3 billion, all the way to 0. Are you ready? What should we count by?
100 millions.
100 billion? All right. Negative 1.3 billion. Negative
1.2 billion.
billion. Negative
1.1
1.1 billion. Negative
Negative 1
1 billion. Now count by 250 million. Go.
Negative
750
million.
Negative
Negative 500 million.
million.
Negative 250
million.
million.
Negative
But
0.
never say negative 0 million. 2, 4, 6,
4, 6,
8.
8.
Who do we appreciate? Mathletes, mathletes, go mathletes. And guys, learn how to make this world safer. Say goodbye to your friends. Enjoy. Find
Thank
me
you.
a solar-powered boat. It is
Bye.
my pleasure.
Everyone.
Miss
See you next
guys
week.
until next week.
See you
Take
tomorrow,
care.
Galaxy.
Bye-bye. See ya.
Bye, Galaxy.